So when we want to graph this, we need at least 2 points. I want at least 2 points and the asymptote to help me graph it. Now, to graph it, I want to think about what x values would make clean, nice outputs. And I also want to think about what the asymptote is, which makes a big, big difference. So to get nice outputs, don't you want your power to equal 0? So what minus 1 would give you 0? So that's going to help us choose out x values. So what minus 1, we want this to equal 0. What would be that? Well, if you solve it, now a lot of you would not need to solve that. You can tell by looking at it that 1 minus 1 is 0. But that's going to be your first x value in your table. So I'm going to make a table. And my first x value is going to be 1. My next x value would just be what's right of that, which would be 2, what's right next to that. So this is my first value. Again, I look at the top, and I go, okay, what makes that a 0? 1. And then create a value next to it. Now I'm going to plug these two numbers in to get 2 coordinates of the graph. Now the weird thing is I got to plug it into this. So here we go. When I plug it in, I'm going to plug 1 in. What's 1 minus 1? 0. So what I have here is I have negative 3 times 2 to the 1 minus 1 plus 4. And I'm just going to do the math. And as we do the math, what you should see, that's 0. So you're going to end up with, right here, 2 to the 0 is 1. So you're going to end up with negative 3 times 1 plus 4. Again, this right here would equal 1. Negative 3 times 1 is negative 3. Negative 3 plus 4 is 1. So there is a coordinate we're going to go over here and plot. Which let's just do it right now. Over 1, up 1. There is a dot on our graph. Okay, so next what we're going to do is we are going to plug in 2. Okay, so let's see what we got. When you plug in 2, it's going to be negative 3 times 2 to the power of 2 minus 1 plus 4. 2 minus 1 is 1. So that's going to end up with negative 3 times 2 to the first, which is 2, plus 4. So negative 3 times 2 is negative 6. Negative 6 plus 4. Negative 6 plus 4 equals negative 2. So right here you get negative 2, so that would be negative 2. So let's plot that coordinate. Over 2. Down 2, so you have a dot right there. Over 2, down 2. There's your dot right there. All right, so we have okay, but what does this look like? Well, I have 2 dots. That doesn't make much sense. Okay, now all exponentials have an asymptote, and what you should notice is this right here is your asymptote. Normally, exponentials had an asymptote right here. Okay, but that is going to be pushed up 4. So this graph is actually going to have an asymptote right here. Okay? So you have an asymptote at right here. So let's write a note to ourselves that the asymptote is always going to be y equals k. Again, this is your k value. That was your h. So it's always going to be y equals k. So for this one, it's going to be y equals 4. That is your asymptote, which it actually asks for. See right here? Find the asymptote. We found it right there. And I drew it in. So the next question is, how do you connect these dots and this to make my graph? And what you should notice is it's a growth graph, because that's bigger than 1. But the negative means it got flipped. So what would a growth graph normally looks like this? If it got flipped, wouldn't it go like this? So it'd be flipped like that, but then it got shifted up. So my graph is going to have that look right there. It's going to look like that. So I'm going to go along the asymptote. Ooh, I'm not curving this very good. And it would look something like that. It's kind of ugly. But because if you think about it, that is a growth graph that would have been there, that got flipped, and it got moved up. So that's kind of how you do it. You first need to think about what values to plug in to make that 0. Get 2 values. You got to notice the asymptote is always the k value. Sketch the asymptote and the 2 dots and make your curve. Exponential growth 30k, depending on what type of graph it is. In order to graph this log over here, what you want to do is choose really wise values. And the wise values are what we think about. We want to think what would make these 1, the base, and those are the 2 values you want here. The 1, you want this right here to equal 1, and this right here to equal the base. So how do we find those? Well, we want to know when x plus 4 equals 1, and we want to know when x plus 4 equals the base, which is 2. So you want what's inside of here to equal 1 or the base. Those are your best 2 values to plug into the log. Easiest 2. So hopefully you can just see that, but if you can't, you just minus 4 over. So this is -3. Here, you minus the 4 over. So this would be x equals -2. Those are your 2 values you want to plug into this problem. Those are your x values you want to choose from. So here we go. I'm going to make a table. And all I need is 2 values. I'm plugging in -3 and -2 into the function. And I'm going to crunch it. You just got to be able to crunch the numbers. And we'll get 2 nice, clean results. Because we started with choosing and trying to make this a 1 and trying to make that the base. Okay, so let's crunch it. What you're going to have here is you have 3 times log base 2 -3 plus 4 minus 1. So let's crunch that. Now right here, what does that become inside? 1. So what you now have is this is going to be 3 log base 2 1 minus 1. Now this right here, you have to find the value of before you multiply the 3 on. And this is saying 2 to what power is 1? So 2 to what power is 1? Oh, that's 0. So this is going to be 3 times 0 minus 1, which I hope that's simple arithmetic for you. You could see the arithmetic right there. That 0 minus 1 is -1. So let's now plug in -2. When we plug in -2, we have 3 times log base 2, -2 plus 4, minus the 1. All right, that would be 3 times log -2 plus, base 2, sorry, -2 plus 4 is 2, minus the 1. So now we have this, because again, that was 2. And this is saying 2 to the what power is 2. So 2 to the what power is 2. Hopefully you know that's 1. So this is 3 times 1 minus 1. And arithmetic says 3 times 1 is 3, minus 2. 3 minus 2 is, 3 minus 1 is 2. So I now have 2 coordinates. Let's plot them. I have my 2 coordinates. So we go plot, okay, -3, -1. There's 1. And then we have -2, +2. Now the weird thing is, okay, I have 2 dots. What? That doesn't help me. Isn't there an asymptote we forgot about? See the asymptote? The asymptote used to be the y-axis, right? Remember, it used to be right here. Didn't that get shifted over left -4? Isn't that axis right there? That got shifted left. Remember, opposite of +4? Negative 4. So wouldn't the asymptote be, the asymptote, let's write that down, is x equals negative 4. There's going to be an asymptote chilling right over here. Chilling. All right? Asymptote was right here. This saying left 4, so we're going to go left 4. There's my asymptote now. So, and then you got to think about how did logs look? Well, logs from our previous graphs kind of go against this asymptote, hit those dots, and have that kind of look. So that's kind of what it's going to look like here when I sketch this. So it's going to go up and kind of near the asymptote, through the dot, and curve up. That is what the graph will look like. Here's your asymptote, here's your 2 dots, and you got your basic graph. Now you could have also graphed this by ignoring H and K and doing shifts, but we're not going to go there. We're just going to find 2 nice dots, find the asymptote, and quickly sketch it.